Hello and welcome back. Today we embark on a journey into the world of Linux system administration and LPIC 1 101.2 module focusing on fundamental aspect, the boot process. I'm Nir and I'm thrilled to guide you through this module, where we unravel the mysteries of booting a Linux system. Have you ever wondered what happens behind the scenes when you power on your Linux machine? Understanding the boot process is like holding the key to the kingdom, empowering you to troubleshoot issues, optimize performance, and importantly, ace the LPIC 1 certification. In this video, we'll dive deep into the BIOS, navigate through bootloader, explore the heart of Linux, the kernel, and explain initiation sequence. Whether you're gearing up for the LPIC 1 exam or simply eager to enhance your Linux knowledge, this tutorial is tailored just for you. So buckle up and get ready for a hands-on journey into the core of Linux system booting. By the end of this tutorial, you'll not only understand the aspects of boot process, but also gain practical insights that will serve you well in your Linux adventures. Remember, this module's weight is 3, so it needs more of your attention. Let's begin. First, let's see what are the key knowledge areas on this module. Provide common commands to the bootloader and options to the kernel at the boot time. Demonstrate knowledge of the boot sequence from BIOS to the boot completion. Understanding of sysvinit and systemd. Awareness of upstart. And check boot events in the log files. And on this module, we're going to use these terms and utilities: dmsh, journalctl, BIOS, UEFI, bootloader, kernel, initramfs, init, sysvinit, and systemd. First up is boot process overview. When a typical PC is powered on, the BIOS detects hardware devices including hard drives and goes through the boot priority list. Assuming we are booting from a hard drive, it will execute the first 512 bytes of the code from the first boot disk MBR. Look at this picture. As you can see, BIOS or your mainboard firmware does a power on self-test or post, and after that chooses the bootable disk, and that disk will have the bootloader. Most simply, a bootloader loads the operating system. Most bootloaders load in 2 stages. In the first stage of the boot, the BIOS loads the part of bootloader known as the initial program loader or IPL. The IPL integrates the partition table and subsequently is able to load data wherever it may exist on various media. This action is used initially to locate the second stage of bootloader, which holds the remainder of the loader. The second stage of bootloader is the real meat of the bootloader. Many consider it the only part of the bootloader. This contains the more disk-intensive parts of the loader, such as user interfaces and kernel loaders. These user interfaces can range from a simple command line to modern GUIs. There have been different bootloaders over time. Lilo was the first, Grub and Grub 2. Let's begin with Lilo. The Linux loader or Lilo is the legacy multi-bootloader for Linux systems. In spite of being the standard choice over the course of several years, it has been slowly phased out. As of January 2006, Lilo is no longer actively developed. Lilo resides in MBR and loads the kernel into memory. Lilo handles multiple OSs on one computer and offers a menu for selection. Its configuration is in lilo.conf, allowing customization. While its relevance is diminished, Lilo played a crucial role in Linux early development. It enabled users to explore Linux alongside other OSs and contributed to its growth. However, due to limitations like a lack of support of modern file systems and configuration flexibility, Lilo has been largely replaced by more advanced bootloaders like Grub. Grub GNU-grub or grub, short for Grand Unified Bootloader, is a bootloader commonly used in all Linux systems. As a bootloader, grub plays a pivotal role in initiating the boot process when you power on your computer. It acts as a bridge between computer's firmware and Linux kernel, managing the loading of the operating system into the computer's memory. What sets grub apart is its versatility. Not only does it allow users to select different operating systems during boot up, especially useful in multi-boot setups, but also provides a configurable environment. The ability to customize boot options, modify configuration, and even access a command line interface for advanced users makes grub a powerful tool for Linux administrators. Whether you are a beginner exploring the basics of Linux or a seasoned user tweaking your system for optional performance, understanding grub is a fundamental aspect of navigating the tricky landscape of Linux boot processes. Grub 2. Now enters Grub 2, the evolutionary successor to its older sibling. Building upon the strong foundation of the original grub, Grub 2 brings a fresh set of features and improvements to the table. Just like its predecessor, Grub 2 is your go-to-go guide to early moments of firing up your computer. It takes the reins during the boot process, ensuring that the Linux kernel and your operating system smoothly transition into action. What is exciting about Grub 2 is its adaptability. Whether you're dealing with the good old text-based interface or prefer a more visual appealing graphical interface, Grub 2 caters to your preferences. It steps up its game to accommodate modern hardware, making it a reliable choice for a wide range of systems. In the realm of multiple operating systems coexisting on a single machine, Grub 2 continues the tradition of being the mediator. It allows you to choose between different operating systems, making it a handy tool for those with diverse computing needs. But wait, there is more. Grub 2 takes customization to next level, with an extension configuration file that lets you tweak boot options, set defaults, and play around with various parameters. It's like having the keys to your system's preferences. Whether you're just starting your Linux journey or you have been around the block, Grub 2 is a crucial part of the boot process that deserves attention. So if you have ever wondered about the magic that happens when your computer comes to life, Grub 2 is the sequel that continues to play a starting role in that story. There are other bootloaders too. You can see some of them in here. We're going to have a chapter for installing a bootloader later on, and we'll talk more about grub on that module. So I think it's a good place to stop and move to the next topic. There is something that I have to clarify first. When I talk about Linux, I really mean GNU Linux, as I mentioned before. Now, in most Linux setups, we're not just dealing with the Linux alone. It's a team effort with the Linux kernel and these handy things called GNU tools. Here's the deal. Linux is like an engine, but it needs a bunch of other tools to run smoothly, like a good-looking interface or a tool to help manage your files. So when I throw around the word Linux, just remember I'm talking about the whole gang, Linux kernel and GNU tools and more. Kernel. The kernel is the core of your operating system, the Linux itself. Your bootloader loads the kernel into the memory and runs it, but kernel needs some initial info to start. Things like drivers are necessary to work with the hardware. Those are stored in initrd or initramfs alongside the kernel and used during the boot. You can also send parameters to the kernel during the boot using the grub config. For example, sending an #1 or S will result the system booting in single user mode or recovery mode. or you can force your graphics to work in 1024x768 mode by passing VGA 792 to the kernel during the boot. The bootloader will point to a kernel often stored in the /boot directory of the file system. The kernel often is loaded in conjunction with an initrd file. The initrd is loaded to give the kernel access to the root of file system and /lib directory. This is where the kernel modules or drivers are located. The kernel is often named VM Linux followed by the version number. If, as in the case of the above screenshot, where you have more than one kernel on the system, you can verify the currently loaded kernel using the command uname-r or by listing the contents of the file proc/version. While we are still in the /proc directory, you can use the file proc/cmd line to show any command line options passed to the kernel at the boot time. That's it for this session. On next video, we'll continue boot process with init process and use more boot process commands. Thank you for watching this video, and if you like it, please subscribe and recommend this channel to your friends.